All right, so let's take a look at perpendicular lines. All right, so you definitely remember that parallel lines have the same slope. What about perpendicular lines? Well, you make a guess, and I'm not going to write anything down. All right, so you make a guess at what the relationship might be for perpendicular lines, and think about the podcast I just did. So this blue and red lines, these two lines here, they are drawn to be perpendicular. Can you calculate the slopes of each? All right, so let's calculate the slopes of each line. All right, so here, there we go. We have the point -6, 4, and we also have the point right here, 0, 0. Actually, both of our graphs go through 0, 0. All right, so let's look at the blue line first of all. All right, so I'll write in blue for the blue line. All right, so our rise, or our line is going down left to right. So it's going down 4, right? It goes from +4 to 0, right? So that's a rise of -4. How about our run? Right, so this was -4 here, and our run here is going 6 to the right. So our slope is -4 over 6, and we can reduce that, right? Those numerator and denominator there are both divisible by 2. So if we divide by 2, we have -2 thirds, right? Because -4 divided by 2 is -2. 6 divided by 2 is 3. Let's calculate out the slope of the red line, excuse me. So 0, 0, and we also have a point over here, and that point is 4, 6. All right, so our rise, it goes from 0 to 6. So here our rise, and then actually, let me just write it over here. I did the slope, there we go. Put the rise in next to the line there. So our rise is going up left to right, so that's a +6. Our run goes from 0 to 4, right? So this is and it's going to the right, so that's +4. So our rise is 6, and our run is 4. Right? So that means our slope, 6 over 4, and that does reduce. Those are both divisible by 2. So 6 divided by 2 is 3, 4 divided by 2 is 2. So now let's look at our slopes. All right, so we have, for the blue line, our slope is -2 thirds. For the red line, our slope is 3/2. Right, so we can see those are definitely not the same slope. And by the way, even before we found the slope, we know they're not the same slope, right? So obvious perpendicular lines don't have the same slope, right? So the blue line has a negative slope, goes down left to right. The red line has a positive slope. It goes, oh, that's not very, it's like positive, has a positive, I'll take my time there, slope. Right? So even if I don't calculate out the slope, we can see that one is positive and one is negative. One's going up left to right, one's going down left to right. But now can we figure out what this relationship is? Right, so just again here, we'll move the red thing out of the way. The slope of the blue line was -2 thirds. The slope of the red line is 3/2. Notice that the same numbers, only they're flipped. Right? Well, they are reciprocals of one another. Not only that, one has a negative slope, one has a positive slope. So these slopes of perpendicular lines are negative reciprocals of one another. So perpendicular lines have slopes that are negative reciprocals of each other. That's a V. I'll make it look nicer. So if you're asked to find the slope of a line that's perpendicular to another line, all you have to do is take the slope of the one, flip it, and change the sign, right? Because perpendicular lines have slopes that are negative reciprocals. Something else that's true. So you can think of them as having negative reciprocals. Also, if you multiply the slopes of perpendicular lines, they equal -1. So for instance, if I multiply -2/3 times 3/2, even if I don't reduce, because I can reduce when I multiply, I can cross reduce when I multiply, even if I don't, I can still see that we have -6 in the numerator, right? -2 times 3 is -6. 3 times 2 is 6. And -6/6, that would be -1. So that's another way you can think of it. So perpendicular lines have slopes that are negative reciprocals. And if you multiply, oops, just wanted to move it. We'll just leave it right there. If you multiply the slopes of two perpendicular lines, their product is always going to equal -1. And that's always true. So let's continue. So the blue and the red lines are drawn to be perpendicular. Can we calculate the slope? Right? So let's look at the red line first. We'll just work left to right. All right, so we can see here that this is to squeeze it in there, a -1. All right, so actually let me put the point. That point there is -8/6. And this point right here is, oh, I lied, I said -1. It's one box, but each box is worth 2. And this point right here is -6/4. Right, so it actually has a rise, if I can squeeze it in there, of -2, right? Because from 6 to 4, right, it's going down 2. And then a run, so from -8 to -6, that would be a +2. So for the red line, the rise over the run, which is our slope, right, is going to be -2 divided by 2, which is -1. Let's do the same thing with the blue line. So we have right here a point 0.6, and this point right here is 2.8. To squeeze it in here. So we have a rise from 6 to 8, right? That would be 2. And we have a run from 0 to 2, also 2. Right? So our slope for the blue line, the rise over the run, is going to be +2 divided by 2, which is 1. So as you can see, as I move the little red boxes, the slope of the red line is -1. The slope of the blue line is 1. Are those reciprocals of one another? As I move the red box. So remember, 1 and -1 are negative reciprocals, right? Because 1 is just 1 over 1, and -1 is just -1 over 1. So if I flip them and make the sign the opposite, you can see 1 and -1 are indeed negative reciprocals. This is already in your notes. That's already there already. So two lines are perpendicular if and only if their slopes are negative reciprocals. Whenever, by the way, we see the if and only if, this works both ways, meaning that if you have two lines and their slopes are, I'll write this down. If two lines have slopes, actually, I can get rid of the if. So two lines have slopes, that over a little bit, that are negative reciprocals. if and only if the lines are, squeeze the red box, squeeze one more word in, perpendicular. So the if and only if means the definition goes both ways. Right? So two lines are perpendicular if and only if their slopes are negative reciprocals. Two lines have slopes that are negative reciprocals if and only if the lines are parallel. Right? So you can know that two lines are, if you know two lines are perpendicular, their slopes are negative reciprocals. If you know that two lines have slopes that are negative reciprocals, they got to be perpendicular. Did I say parallel? Perpendicular. I think I said perpendicular, but so perpendicular. Okay? So now you know how to determine if lines are perpendicular. You look at their slopes. Are they negative reciprocals of one another? If yes, they are perpendicular lines. If no, then they are not perpendicular lines. Right? This is not in your notes, but find a little space and write it in. Right? So here we have a vertical line and a horizontal line. The equation of the vertical line, by the way, is x equals -3, because it has an x-intercept of -3. The equation of the horizontal line is y equals 3, because it has a y-intercept of 3. Technically, we could also write it as y equals 0x plus 3. That would be the same thing. All right, so horizontal and vertical lines are always perpendicular. Right? So the horizontal line has a slope of 0. The 0 is going to be in the numerator. The vertical line has an undefined slope. The 0 is going to be in the denominator, and they are always perpendicular lines. So I'd like you to add, just find a place or add a sticky note, add this part to your notes. You don't need to add the graph unless you want to, but please add that part in your notes so that you have it. Okay? So now you know how to find the slopes of lines that are horizontal or vertical, because a negative reciprocal doesn't exactly work when you're talking 0, which is never negative, and undefined, which is also never negative. But notice that 0 is in a different location, the numerator or the denominator. And we can see, right, that a horizontal and a vertical line, they must be perpendicular, right? They're definitely meeting at right angles. Right, as we continue. All right, so we're going to do some questions together. Are these two lines perpendicular? So don't ever answer yes or no without showing whether it is yes or no. All right, we have to show that we have slopes that are negative reciprocals. And I should say are or are not negative reciprocals. All right, so let's take a look and find the slope of the blue line. Right, and I have 2 points there, right? 3, 4, 0, 2. Right, so I'll use those. Right, and it doesn't matter which is first and which is second. I'll just work left to right. Right, so I've got 4 minus 2 in the numerator, and difference in the x-coordinates, -3 minus 0. So that's going to give me 2 in the numerator, -3 in the denominator. And it doesn't really matter where the negative is. That's still a -2/3. Let's find the slope of the red line. All right, so I'm going to use 0, 2 first. I'll just go left to right. So I've got 2 minus 6 divided by 0 minus 3. 2 minus 6 is a -4, and 0 minus 3 is a -3. So the two negatives cancel out, so 4/3. Well, notice they are different signs, but they are definitely not reciprocals of one another. Yeah, let's move my, stop blocking my writing. So lines that are not perpendicular, the slopes are not negative reciprocals of one another. So when you're asked to determine whether or not lines are parallel or perpendicular, make sure you find the slopes. If they have the same slope, you'll know they're parallel. If they have slopes that are negative reciprocals, they are perpendicular. And if they're not the same and they're not negative reciprocals, they just have intersecting lines. So these are just intersecting lines, nothing special. If you were to look at it, you might say, hey, that looks kind of perpendicular. It really does. But it's not, right? Because our slopes are not negative reciprocals, right? So eyes are, deceiving, right? Make sure you prove that they are or they are not, right? And now we have. Let's circle. Let's circle our answer. So our answer was big old fat no, not perpendicular. Right? Let's do another problem together. All right, so we want to show that the two lines are perpendicular, parallel, neither. Right? And so we need points so that we can calculate the slope. Here's a nice point to use. That's the point -2, 0. Very clear. That y-intercept, not clear at all. So let me get another point nice and clear. And I think right here is my best bet. Right there we have the point 1, 4. Right, on the other line, the y-intercept's nice and clear. 0, -3. The x-intercept is not, so we can't use that point. It's probably a lot clearer if I look on my computer as opposed to on the smartboard where I'm trying to see where the lines intersect and I have integer values. This one's a little tougher to see. Let's see. Well, not at 1. And definitely not at 2. Not at 3. How about at 4 if I follow it up? Yes, 4 is good. There we go, 4, 2. All right. It's a little faint for me when I'm looking on the whiteboard, a smartboard, with the projector light behind me. All right, so now let's find the slope of the blue line. I'll write in blue for blue line. All right, so again, difference in the y-coordinates, and I always work left to right, just easier for me. All right, so we have 0 minus 4 divided by -2 minus 1. So that's going to be a -4 divided by a -3, which is 4/3. Hey, that was the same slope as the last line. It's not the same line, it's different y-intercept, but same slope. All right, so let's find the slope of the red line. Right, so we've got, I'll work left to right. So we have -3 minus 2 divided by 0 minus 4. So that would be -5 divided by -4, which is 5/4. So by the way, we can see that these lines both have a positive slope. Right? They're both going up left to right. And so they obviously can't be perpendicular because they are never, they're definitely not negative reciprocals of one another. One's not negative, they're both positive. However, they're also not parallel lines because we don't have the same slope. They are neither. Right? So here are slopes. Are not the same. So we don't have parallel lines. Or negative reciprocals. Handwriting tends to get worse at the edge of the board because I'm having to reach. There you go. So they're not perpendicular lines. I'll just use this symbol for perpendicular. What they are, by the way, is intersecting. Even though they do not look like they intersect on the graph, because they're not parallel, eventually, and they're in the same plane, right? They're on the coordinate plane right in front of us. They will eventually intersect at some point. It may take a long time, and I will run out of space on that graph before it happens, but eventually those two lines will intersect. So if the lines are not parallel and they're not perpendicular, they're not just two equations that are the exact same line, They have to intersect at some point. That's the last problem. Right? So I put a little screen so I would know I am at the last problem. So thanks for watching this podcast. All right, in the next podcast, we're going to look at some graphs of perpendicular lines. All right, so bye for now.